Today we're going to talk about logical data modeling. One of my personal favorite modeling choices, by the way, because it is so versatile and so incredibly useful. I use it all the time in my database work, and logical data modeling bridges the gap between the ERD, which is a very high level, and the physical model, which you're going to use to actually implement a database. So I think you'll get into it, and let's see what logical data modeling is all about. In the last video, I introduced the idea of business rule. Business rules are extremely important in that they allow us to document the data rules for a particular organization, and they allow us, ER diagrams allow us to actually document those rules. So that was what we covered last time. We also talked about minimum and maximum cardinalities, which we reviewed in class a little bit. It was in the first quiz. And then we also talked about how to draw ERDs with Visio. Today's video focuses on only one topic, but it's an extremely important topic, and that is how do you create a logical data model from an ERD. There's a nice flow from entity relationship diagrams, or ERDs, to logical data models, and we're going to cover that so that you can see how that high-level model helps you along later. To create a logical data model from an ERD, there's specific steps that have to be followed. And we're going to go through these steps carefully. For your reference, these steps are listed in page 25 of your course pack, so you can go through them very carefully and read them much more carefully here. And my goal here is not to cover all the material. It's to walk you through a simple example that you could do on your own. So let's take a look at these steps. Number one, with an entity relationship diagram, you only list entities. But the reality is, of course, that you've got attributes. I mean, an attribute is some characteristic of the entity that you want to be able to store. And you could think of these, for example, as fields in your database. So, for example, for the employee entity, you might have last name or first name. So these relevant attributes are going to be important, and we have to decide where they're going to go. For the simple examples we're going to do today, it's going to be pretty straightforward. And when we get into normalization in a couple of weeks, you'll see, though, that in some cases, placing the attributes in the appropriate entity requires a little bit more discipline and more of a structured approach. But for today, we're just going to take it nice and easy. We'll do some simple examples. Step two is to specify a primary key for each entity. Now, a primary key is an interesting concept. A primary key means that each row in your particular database, or I'm sorry, your table or entity is uniquely identified. Now, a primary key often is very easy. Social security number, for example, or an employee ID, a vehicle identification number for a car. So sometimes those are very natural things that are out there. But in other cases, we may have to actually create a primary key that's an artificial key, but it still will function for us. So that's step two. Step three is going to be to label all weak entities. Now, we haven't introduced the concept of a weak entity, and I'm going to spend more time on this in a future video, and of course we'll talk about this in much more detail in class. So I'm going to skip over this step for now, but the concept of a weak entity is very important, and we will cover that in class and in a future video. And then step four is the final step, and that is we have to actually create what are called foreign keys in each relationship. Now, foreign keys are a very important concept within relational databases. For each relationship that we have, we're going to have at least one foreign key. And for each foreign key, we're going to have an associated relationship. So those two go hand in hand. As a matter of fact, this is the way that a relational database actually implements the relationship between the two entities. So it's very important that we get this right. There are a lot of different approaches to this depending on the nature of the relationship. And these are the rules that I want you to remember. So for binary just means that there are two entities involved. For binary one-to-many relationships, which by the way is going to be the lion's share, it's going to be the vast majority of ones that we have, we're going to take the primary key from the one side, and that's going to become the foreign key on the many side. And we'll go through that in just a minute. For binary one-to-one relationships, we've got some more decisions to make here. If we have a situation where one side of the relationship is optional and the other side is mandatory, we're going to take the primary key from the mandatory side and we're going to make it the primary key on the optional side. If both sides are optional in the relationship, that is, they have a minimum cardinality of 0, then we can choose either primary key to make it a foreign key, and we'll actually see that in this example. And then finally, if both sides are mandatory, and by the way, this is very unusual, and in general, by the way, one-to-one relationships are kind of unusual in and of themselves. They make a fairly small percentage of the relationships. Normally, it's a one-to-many relationship. But if you do have a one-to-one relationship and both sides are mandatory, the rule of thumb is that usually the two entities can be combined into one entity, and you can just eliminate the relationship. And then finally, of course, the other option is that we have a many-to-many relationship. And this, again, is kind of has a special topic, and this is something that we're going to have to talk about. Many-to-many relationships come up quite often, but at the same time, it requires a dedicated video to actually cover it. So let's take a look at an example. We have an entity relationship diagram listed here on the screen that involves computers, employees, and a department. So our business rules are listed here. Within the business rules, we have an employee must be assigned to a department, and only one department. So if you look at the relationship between employee and department, it's pretty clear here, given this relationship, that each employee is assigned to one and only one department. That's a mandatory relationship. At most, an employee can be in one department. Going the other direction, a department can have many employees assigned to it. So a department, for example, can have many employees, hence the crow's foot, or a department could have 0 employees. In other words, a department doesn't have to have an employee. So that's this relationship. The other relationship involves employee and computer. In this situation, an employee can be assigned at most one computer. It'd be great if an employee could have many computers, but we're going to be pretty conservative and say, if you get a computer, you only get one. You don't have to get a computer, but if you do, you're only going to get one. So an employee can have 0 to 1 computers. And of course, a computer is not going to be shared by employees, so a computer could be assigned to only one employee. And a computer may not be assigned. A computer may be just laying around waiting to be assigned. So in both cases, both sides of the relationship here are optional. So that makes up our ERD. You'll also notice that we have attributes over here. Now, typically in an ERD, we don't list the attributes, but I'm including them here so that you can take a look. In this situation, of course, as I mentioned in the intro, the attributes are pretty easy to assign. We have a computer make and model, which of course are going to go in computer, and the serial number is going to go in computer. We have an employee ID, an employee last name, employee first name. Those are obviously going to be assigned to this entity, and then we have the department name, which is going to be assigned to the department. Okay, so what I did here to make it a little bit easier for you to see is I've put the ERD on the left side, and then I moved created the beginnings of an LDM on the right side. With a logical data model, like I said, you assign each of the attributes to a particular entity, which is what I've done here. So computer, for example, has the serial number, the make, and the model. Since serial number is unique, a computer can only have one serial number, and a serial number can only be a part of one particular computer. That's going to act as our primary key. That's going to uniquely identify the computer. For employee, I assigned last name and first name, and of course each employee has an ID or a number, and so I've made that the primary key. And then finally, we have the department, and the department has a department ID, which I just created, by the way. We did not have a department ID, and as I mentioned in the beginning, sometimes you just have to create a primary key. Now in practice, this is going to simply be an auto number field if you've ever had access, which means it's just going to increment each time we add a new column to the database, or a new field to the database, a new record to the database. But we're going to go into that when we get to the physical implementation of the database. For now, for logical data models, just know that sometimes it's necessary to create an ID when one does not exist, and then of course the department name is going to be assigned to that department. The business rules, again, we can get those from the relationships here, and what I did was I copied the rules of thumb here for to assign the foreign keys. Now the interesting thing about Visio is that Visio will actually map the foreign keys for us depending on how we set up the relationships. So that's very important to know. Now, up till now we have not done that, and I have not shown you how to do that, so I don't want you to panic. We will do that in a future video as well. I'll show you actually how to create a logical data model using one of Visio's dedicated templates. But for now, let's just walk through it and you'll see how this actually works. So with regards to the one-to-many relationship, we've got a department and we've got an employee. And you'll see from the ERD that a department can have many employees, as we mentioned. So I'm going to take this relationship here and I'm going to pull it over, and you'll notice that it has automatically a one side here and a many side. So we want to make sure that we connect the right part. So I'm going to actually put this over here, and I'm going to paste that right there till that turns red. And then I'm going to take this part of it and I'm going to put that there. And now you see it's kind of tight here. I'm not going to worry about the name of the relationship here, but I just want to make sure that these are correct. And as it turns out, it is pretty much, although we have actually an optional on this side, and so I'm going to need to fix that. So you can see now with the relationship drawn in, we have the relationship looks very similar to the entity relationship diagram in the ERD. As a matter of fact, it's pretty much identical. But you may also notice what happened. If I take this relationship off for a second, notice that department ID disappears. Let me connect it again. Okay, so when I draw it, what happens is that the department ID goes automatically in Visio from the one side over to the many side, which is exactly what we said the rule is. So in the case of one-to-many relationships up here, the primary key from the one side becomes the foreign key on the many side. So the nice thing about Visio is that it does it for you automatically. Now I'm going to fix the cardinality over here by making department ID required, and we will talk about this later in class, but for right now let me just get it so that it works and it's identical to what you expect. There we go. Let me close it out. So now you'll see again that the primary key on the one side, which is department ID, became the foreign key on the many side, and that's the rule that we're going to be using throughout the class for mapping foreign keys. Okay, so we have another relationship to add. Let me go ahead and do that. So let me pull this in, and we've got our relationship, and I'm going to put this is optional now on both sides. So I'm going to connect this here, and I'm going to connect this here, and you'll see that, let me move this over just a little bit. You can see it a little better. We have very little space here. So you'll see it's optional on both sides, and I can fix that now by fixing the relationship. So let me go ahead and do that. Serial number to serial number, as you see, and then we will change this to be 0 or 1. There we go, and you will now see. Now Visio makes a decision here, and because you can do it either way, what it does is it automatically maps the primary key here on this optional side and then moves it to be a foreign key here on the other side. Now this could go either way. According to our rule, here it says if both sides are optional, you may choose either primary key, make it the foreign key in the other entity, and that's what Visio has done for us automatically. So this gives you an idea of how to actually implement a logical data model given a certain ERD. So this gives us the foreign keys here that are in the employee table. You'll see they're labeled here foreign key 1, foreign key 2. And those support the relationships. Again, it's very important to remember that whenever you have a relationship, there will be an associated foreign key, in this case the serial number, in the employee table. For this relationship, you'll have an associated foreign key. And in this case, it'll be the department ID. So each foreign key is associated with a relationship, and each relationship is associated with a foreign key. Alright, this is the exercise part, and so I'm going to leave you with an exercise to work on your own. And you can see the ERD here. We have an employee who can have 0 to many paychecks, and we have a paycheck, and a paycheck certainly is associated with only one employee. It's got to be associated with one and only one employee. On the other side, we've got an employee who might be lucky enough to get a car, but probably not too surprisingly, we're not going to give them multiple cars. We're going to only give them, at most, one car. And of course, it's possible that we don't give the employee any car. So that's this relationship right here. Going the other way, a specific car, we're not just going to let it sit around in the parking lot. Cars have to be allocated to a specific employee. So I guess you can guess what I'm going to have you do. I've listed here some attributes that you might work on. We have employee, last name, first name, etc. So your exercise is to create now a logical data model using the provided attributes. This should be pretty straightforward given the exercise, but again, this will help you on the quiz. So the topic of conversation today was really an important one. We talked about, or I talked about, how you can take an entity relationship model and turn it into a logical data model. And this is very important because this is going to be our interim step. It's going to give us some really great insights as to how to implement a database given a certain set of business rules. And the rules that I've given you are going to cover the vast majority of the situations for the rest of the semester. Now, in future videos, we're going to talk about things such as the reciprocal relationships. We're going to talk about what's called supertype subtype relationships. We're also going to talk about weak entities versus strong entities. These are all important topics, but today was very important in terms of covering the idea of logical data models. Talk to you soon. Take care. We'll see you in class.